So based on our previous discussion, now we are talking about how do we partition these two arrays in such a way that left side has 6 elements, right side has 5 elements, and we also want to make sure that all the elements on the left side are smaller than all the elements on the right side. So what we will do is we will apply binary search on the left side to find the optimal partition point. So partition points are usually like here. If we partition this, we are saying 0 elements of A are selected in the left partition. And here if we partition, it's like one element of A is selected, and here if we partition, we are saying all the elements of A are selected. Now we will take the binary search approach. So we will start with that in A, low is 0 because we can partition at 0th point, or we can partition at this highest point 5. So we can say our high is 5. So these two things we have taken. Low is 0, high is 5, and based on that we calculate how many elements of A, count of elements of A that we have to take. Now for that, let's apply our binary search formula, L plus H by 2. If you want to avoid overflow, you can use L plus H minus L by 2, but here we will stick to this formula. So it is coming out to be 0 plus 5 by 2 comes out to be 2. So first we are trying an approach where we say, hey, if we divide it at this point such that 2 elements of A are selected, then see whether we can reach a solution, whether we can reach any conclusion. So this is our first point with which we are starting. Now if that is the case, that means we are taking element 5 from here and 15 from here. 2 elements of A are taken on the left side, and remaining 3 elements will go to the right side, 21, 35 and 55. So this is partition of A that has happened. Now based on this number 6 that we want to accomplish or achieve in the first partition, we can figure out how many elements of B are required. So here the partition for B will come out to be 4, and eventually if you see that is equal to the number of elements required, you can say that is len, and minus you can say AC. So if you see BC is being derived from AC. So this 6 minus 2 gives us 4. So we are saying 4 elements of B will come to the first part. So those 4 elements of B are 11, 22, 33 and 44. Now remaining B elements are 66 and 99. Now we have reached one partition, and after we reach this partition, we try to validate our premise. Are we having all the elements on the left side to be lesser than all the elements on the right side? Because if that is the case, then 44 would have been our median. But what we notice here is there will be two cases possible. First case is this, that here the value of A will be greater than the value of B. So this is called B of BC minus 1. That will be the value here. And this will be called A of AC. Because you remember we have divided it based on this AC. And since AC is there, then we can say that here the indices are 0 and 1, which is AC minus 1. And here the indices are 2, 3, 4. So this I'm saying let's compare A of AC with B of BC minus 1. If here A of AC is greater, this is one possibility that can happen. Or second possibility could have been, which is not the case here, that this could have been bigger than this value. Only these two possibilities we can say are there. Otherwise, everything here will be smaller than everything here. So these three cases, if we learn to understand or learn to code, that is good enough, right? So let's go back to the previous step. And what we determine here is that all the elements on the left side are not smaller than all the elements on the right side. And now we understand who is violating this rule. The rule is being violated by, there is an A element which is smaller than a B element here. What this indicates to us is that this A element ideally should have been pulled on the left side. So there is one A element that is violating the condition. If we pull 21 this side, then certainly, like if one more element comes from A and we have to maintain a count of 6, then something from this will get kicked out. So this 44 will get kicked out. So this is what we are trying to accomplish. Now how do we make this conclusion that A has to be pulled in, and how do we pull that in is a question. Now if this A is smaller than our this element, then we are saying we need to include more elements, and more elements can come only when we move to the right side. So here what we are talking about is, like in binary search, after calculating the mid, we decide our low and high should be updated. Here also same thing is going to happen, that we are going to update our low here, we are going to update our low here to, it will take a new value of AC plus 1. So AC plus 1 because we are moving to the right side, and low will become 3 now and high is anyways 5. So this is the decision we have made here, and through this decision what will happen is 21 will also come to this side, right? Because this low modification will make sure that our AC value gets updated. So let's try that. So previous thing has led us to a point where we have to update our low to some other value, and let's go and say now our low becomes 3, high is 5 already. So what will our new AC be? Our AC will become equal to low plus high by 2, which is 5 plus 3 by 2 comes out to be 4. And that's where the next step begins. Now if 4 is the division point, that means from first array we are taking 4 elements, which means 5, 15, 21 and 35 are there from A, and from B certainly we'll take 2 more elements because 6 has to be preserved. So BC also gets changed. So here BC will be updated to 2, and those 2 elements of B that we take are 11 and 22. And on the right side from A array we get only 55, that's the only element left. And from B array what we get is we get 33, 44, 66 and 99. So this is the new division that we have come to. Now whenever we come to a new division, again we should try to validate, does this partition meet the criteria that all the elements on the left side are smaller than all the elements on the right side? And here we can say this is again violated by this element. There is one A element which is actually greater than a B element. So if this is the case, then eventually we determine that hey, this A should have been kicked out. So if we are trying to say like this A should have been part of the right partition, that means our high is moving to the left. So here our AC was 4. So high will get changed to AC minus 1. So eventually you will see here L is 3 and high will become 4. This is the next point we have reached to. So our L is 3, H is 4. So AC we have to calculate once again. So AC, if we calculate 4 plus 3 by 2 will eventually come out to be 7 by 2 is 3. So now we are up to a point where we are saying, hey, division at point 3 is better. And let me erase this so that we can start tracing from that point onward. So all this we have understood. We have gone 2 steps and we are kind of again doing binary search on the left side. So now our AC that we have got has come out to be 3. So if AC is 3, that means from first array we are taking 3 elements here, and from second array other 3 elements will come. So 11, 22 and 33 will come, and first array's remaining elements are 35 and 55, and remaining element of second array are 44, 66 and 99. Now once we reach this point, again we try to check if this A is smaller than this B, that condition is true, and this A is greater than this B, even that is true. So this is greater, this is greater. So our worry has gone that, okay, we have divided arrays into 2 equal parts, and out of these equal parts, now what we determine is, since first array has one number extra, that extra number out of these 2, whichever is the maximum value, that is going to be our median. So we have found the answer to be 33. This is the median. And if elements, imagine, were equal, and imagine here 88 was also there, in that case our original array's elements would have told that total elements were even in number. So we would have said the maximum from here and minimum from here, 35 and 33's average would have been our median. So I mean, it's not difficult now to do the even sum kind of array tracing. If you have understood this point, just try to internalize it, try to think about it, how we are applying binary search, and you will notice that binary search is being applied only to the array A, not to array B. And based on A only, we were determining 6 minus AC was giving us the value of BC. Now because we are calculating BC on this formula, we should always make sure the array that we are keeping on the left side should be smaller in size, because only then this value will remain positive. So if you get array which is B array is bigger than A, then we should apply our logic in such a way that our B array should become the first array and A should become the second array. That we will see when we come to the code, but keep that in mind. In this approach, the trickiest part is we have kept A as the smaller array than B array, and that led us to a solution of binary search that we have accomplished.